Hello everyone, I am Dr. Rajesh and I am with you with my new video lecture. And in this video lecture, we will learn about apse and apsidal distances, and we will also cover some important theorems upon these apse and apsidal distances. So, firstly, we should learn what is apse. The definition of the apse is given by this is the definition. We should try to understand the definition. Apse is a point on a center orbit at which the radius vector drawn from the center of force to this point has distance maximum or minimum. We will learn it through an example. So let us take this figure, which is an elliptic orbit. We will be able to understand the definition, and understanding the definition is the most important thing. Now let us read it out. The definition again: a point on a center orbit. This is center orbit. This is the center of the force. Point on a center orbit at which the radius vector drawn from the center of force to this point has maximum or minimum value. The minimum value from this center orbit could be this thing only. So this is the minimum distance. So this radius vector drawn from 3 to r, and this is the maximum value because ellipse is in flattened form. So this is the maximum value. So 2 and 1 are apse in this particular case. 2 is corresponding to minimum value and this is corresponding to maximum value, and this is maximum because it is in the flattened form. Ellipse is in the flattened form. So this is apse and this is also apse. So apse is a point on center orbit. This is the center orbit at which the radius vector drawn from the center of the force, the center of the force, to this point has either minimum or maximum. So 1 and 2 are the apse in this particular central orbit. And what is apsidal distance? The distance between this apse and this center of force, this radius vector, is called apsidal distance. The distance between an apse and the center of force is called the apsidal distance. So this distance is called apsidal distance. This is also apsidal distance. So we have learned the concept of what is apse. And apse is that point on the central orbit whose distance from the center of force is either minimum or maximum, and the distance between the apse and the center orbit is called the apsidal distance. So we have understand the definition, and understanding the definition is most important thing as far as learning mathematics or learning anything is concerned. This is the figure. Now we will see a concept. Since say this r is apsidal distance, and you know u is equal to 1 by r. At apse, r is either minimum or maximum. Okay, fine. This implies that u, which is reciprocal of r, is also either maximum or minimum. I have written in the opposite order because it is reciprocal. Here I have written minimum, I have written maximum. Maximum, minimum. So this is either maximum or minimum, and for maximum minimum we know that du d theta will be equal to 0, where theta is the apsidal angle. Apsidal angle is angle between two consecutive apses. So that is apsidal angle. So this du by d theta will be 0 because u is either maximum or minimum, and this is the condition of maximum or minima, that du by d theta is equal to 0 at apps. So we will be using this particular result frequently. Whenever we will talk about the apps, we will be in a position to use that particular result, that du by d theta will be 0 at apps. Next we see the important theorem, and the statement of the theorem is, see what we have to prove. We have to prove that at apps the particle moves at right angle to the radius vector. So the motion of the particle is given by tangent drawn. So this is the tangent drawn at this particular point, and we have to prove that this tangent is perpendicular to this, so this angle is 90 degree. So, and we know that angle between r and tangent is phi. So in turn we have to prove that at apps phi is equal to 90 degree. So understanding the theorem is very important thing. So in the theorem it is being asked that prove that at apps the angle between the tangent and the radius vector is 90 degree. So we will be proving the theorem. So for that we know that 1 by p square is equal to 1 by r square plus 1 by r4 dr d theta, where is the length of the perpendicular drawn from the pole to the tangent at any given point p. So we have already studied about this p. So we know that r is equal to 1 by u, or u is equal to 1 by r. So substituting over there, p square is equal to u square plus u4, and dr by d theta can be calculated by minus 1 by u square du d theta. So put it over here, minus u square du d theta whole square. This is further equal to u square u4 du d theta whole square. This will cancel out. This will be u square plus du d theta whole square 1 by p square. And at apps we have already discussed that du d theta is equal to 0. Then substituting in equation A, we get p square is equal to u square at apps. Now u is 1 by r, so this will p square is equal to 1 by r square. This implies that p square is equal to r square. This implies that p is equal to r. This further implies that, and p you know is r sin phi. In the earlier videos I have shown that p is equal to r sin phi. You can consult my previous videos, there I have shown that p is equal to r sin phi. So this will cancel out. This implies that sin phi equal to 1. This implies that phi is equal to pi by 2. Now if we once again see what is phi, so this is the figure that will help us in locating and understanding the meaning of phi. This is any point p on the center orbit. This is the tangent drawn, and this is the radius vector. This is the radius vector. This is the length of the perpendicular drawn to the tangent. Now from this it is very much clear that p upon r is equal to sin phi in triangle OAP. So this implies that p is equal to r sin phi. Therefore this angle phi we have proved that is pi by 2, which is the angle between the radius vector and the tangent. So if we again see the figure, this one, in this we have shown that this is the radius vector and this is the tangent at the apse. So the angle between the radius vector and tangent is phi, which is we have proved is 90 degrees. So this proves the theorem where we will prove that radius vector is perpendicular to the tangent. So this is the all from this lecture, and in the next lecture, which I will be sharing very soon, we will be studying an important question from the examination point of view, and please don't miss that lecture. And if you have liked the video, please like, subscribe, share and comment, and your comment in the comment section are valued, welcome and appreciated. So this is all I have from this lecture. This is Dr. Rajesh saying you goodbye. Thank you.